All right, this video is on how to graph piecewise functions and then also talking about the definition of them, like what are they? So in this blank space, you can write a piecewise function is a function made up of pieces of other functions. Each function is graphed for a particular interval. So what we mean by this is, for instance, in example 1, this piecewise function has two different pieces. They often have two, but they could have three pieces. If I was mean, I could give you one that had 57 pieces. But the way that it works is we say it's going to use this linear piece if the x value is left of 1, so less than 1 would be the left side of the graph. And then it's going to use this quadratic if x is greater than or equal to 1, so that would be the right side of the graph. And so that's what we mean by piecewise function. That's one piece for one part of the function and another piece for the other part. So when we graph these, we're going to use pencil. So if you have a pen in your hand, you need to switch to pencil. And we're going to go ahead and start by graphing the linear portion first. So it says x plus 2. And if you forgot, that's y equals mx plus b. So that would be 1 over 1 x plus 2. And so that means we have a y-intercept of 2 and a slope of up 1, right 1, up 1, right 1, up 1, right 1. And what I'm going to go ahead and do is very lightly, I'm going to draw that line. And then I'm going to do this part where I see that this equation of the line has a limited domain. So they are saying the interval that we're using it for is anywhere that the x value is less than 1. So I take that value of 1 and I find that x value on the curve, or in this case on the line. So I look for x equals 1, which is right here, and I circle it. If you can equal that number, you fill in the circle. If you can't equal that number, you do not fill in the circle. So this just says less than 1. It doesn't say you can equal 1, so I am not going to fill in the circle. And then what we do is we take the part of the line that makes this true and we make it dark. So x values that are less than 1 would be like an x value of 0, an x value of -1, x value of -2, x value of -3. All of these numbers that are to the left of 1 are the ones that would be true. So we make it dark, draw an arrow because it would go forever, and then I go back and I erase the other part of the line. And that's why you're using a pencil. All right, and then I can go ahead and do the other part. So that's a quadratic or a parabola, and it would have a vertex of +1, 0. And so when I graph this and look at my table, +1, 0 is what I'm going to be looking for to make sure that I get all the points that I need. So +1, 0 is right there. So I'm going to look at +1, 0, and then I'm going to do the points on either side of that. So I have 0, 1, 2, 1, -1, 4, 3, 4, -2, 9, 4, 9. So those are all the points that I could see on here. Again, I'm going to very lightly draw that shape. And then it says that I'm looking at an x value of 1 again. So on that curve, I find where x equals 1 and I circle it. And then here it says that x can equal 1, and so I'm going to go ahead and fill in that circle. And it wants me to keep the part of the line that is greater than 1. So here's our x value of 2, our x value of 3, our x value of 4, and so we're going to keep that part of the line like that. And then the rest of it needs to be erased. Okay. So when you're done with these, if you want to check them in a calculator, you can. There's a special trick for plugging them in. So if you're doing this at home, then you should be following along with me right now so that you can practice it. So the way that we do this, if we want to plug in x plus 2, but only for the parts where x is less than 1, then I put divide by to kind of separate it with the next thing I'm going to write, and I put a parenthesis. So divide by parenthesis, and then I'm going to put that limited domain in there, so x. And then to get the less than sign, I have to type second math. So second math, and then it lets me put in my inequalities. So now I'm going to go through and put a less than sign, x is less than 1. And then I'll go down, I can do my end parenthesis. Nope, I already did it. Okay, now I can go down to the other one, x minus 1 squared, and now I can hit divide by and parenthesis, and I'm going to type x is greater than or equal to 1. So x, to get my greater than or equal to sign, I hit second math, greater than or equal to 1. And now if I go ahead and graph that, I'll change my window back to normal, then it looks the same as what we just graphed on our paper. Okay, now our graph is not going to show that this right here is a hole, a circle that's not filled in is a hole, and it's not going to show that this is a point, but we get the idea. Okay, let's try the next one. So this one just says -3. It doesn't say mx plus b, it just is a number. And so what that means is that y equals -3 always. No matter what x value I plug in, the y coordinate that goes with that is going to be -3. So I get the point 0, -3, 2, -3, 7, -3, -4, -3, -8, -3, and that actually makes a perfect horizontal line. All right, and it says if x is between -5 and -1. So here's an x value of -5, here's an x value of -1. I do not fill in the -5. I do fill in the -1. And it says I'm using everything between that. So I'm going to make between it dark, and then I'm going to erase the rest. Okay, now it says -x squared plus 4. I know that that is a vertex of 0, 4. And so that tells me that that's where I need to be looking when I graph this to find some other points to plug in. Or not to plug in, but find some other points that I'll be graphing. So 0, 4 is right in the middle. And then I have -1, 3, and 1, 3, -2, 0, and 2, 0, -3, -5, and 3, -5. So I'm going to go ahead and trace this and make it pretty light. Okay, and it says that I'm starting where x equals -1. So where the x coordinate is -1, I put a circle. I do not fill it in because it can't equal -1. And then I'm saving the part of the graph where x is bigger than -1. So x is 0, x is 1, x is 2, x is 3. I'm keeping all those parts. And then the rest of it can be erased. And then we'll practice plugging ones like this into the calculator in class because this one's a little bit trickier to plug in. So that's the gist of it. Basically what you want to do is you want to look at the different pieces. You're going to start off by graphing the whole piece, whether it's y equals mx plus b, and you know how to use that. You can graph that by hand without using a calculator, or if it's something else, one of the other parent functions we've looked at, and you can graph it using a calculator. You graph the whole thing, and then you use this to figure out how much you should keep and what part you should erase. So if you need to write something in your notes about which numbers get filled in and which ones don't, the ones that do not have an equal to do not get filled in. The ones that do have an equal to do get filled in. And so that might be something important to put on your notes.